Okay, everyone. Well, you're in the last chance saloon now for feedback forms. I'm not going to mention it again because I've gone on and on about it, and you've had a really good opportunity to fill those in. So we're now going to welcome Anthony Holmes of Cambium. Anthony is the VP of Millimeter Wave Products. Hello, Anthony. How are you?
Hello, Brian. I'm fine, thank you.
Now, I was trying to find out something about you, you see, to sort of a little comment, and I wasn't getting anywhere. And then, completely out of the blue, I found out that you are a free fall parachutist. Now, that's pretty spectacular.
Many years ago, yeah, when I was in the OTC, yeah,
So,
officer training.
so if Cambium needs someone to get into a customer issue or opportunity, they could literally parachute you in to look after it.
Many times, yes, I'm here and available. I can do that.
Okay. Okay, so you're going to give us a presentation and some examples actually of deployment of cnWave, and then I think there's also going to be a video after the presentation. And there's some questions come in. I'll talk to you after the video.
Brilliant. Okay, thank you very much.
Over to you.
Thanks. So normally the last presentation of the day is a dodgy one. Everyone's sort of desperate to get off to the bar or the buffet. So with this virtual conferencing, I get a little bit more leeway. So hopefully I can keep you interested for the next 20 odd minutes. Okay, over the past 6 months, there's been a dramatic increase in the awareness of fixed wireless around the world. Basically, it's being driven by a confluence of factors. That includes the demand for broadband due to the 5G, and also COVID as well, making people wanting more distributed broadband access. There's another exciting reason as well, we think, which is the arrival of the new 802.11ay standard and Terragraph platforms becoming available for multi-gigabit wireless access. The timing couldn't be more perfect for this game-changing technology. With technology, it's now possible to deliver reliable multi-gigabit wireless broadband at the edge of the network. All right, so over the next 20 minutes, I'm going to give a brief overview of the technology and the architecture that's made this possible. And I will focus on a number of the deployments we actually have out in the field now and being used. So what is this about? In the past, fixed wireless access is in people's heads been right up the top of a mast. And don't get me wrong, we have a place for this. This is providing broadband access to a large area, but we're moving this down to the street corner, from the mast to the street corner, making it easy for anyone to deploy a multi-gigabit radio system, as easy as putting up Wi-Fi access points. So what's changed? In the past, 10 years ago now, we had the 11AD standard, and that's great for high performance point-to-point over short distances. However, go to point-to-multipoint and it suffers. So in 2020, the .11ay standard came along, and Qualcomm and Facebook technology was introduced into that, and they've helped guide and put many changes into that standard. So what does that mean for you as a customer? You've still got the same very wide channels. That's 2.16 gig channels. But now you're actually capable of transporting around about 3.6 gigabits per second on each one of those channels. With channel bonding, you're able to potentially double that data rate, getting over 7 gigabits per second on a single channel. On a single channel bonded channel using two of those. With scalability, you've now got a total cost of ownership is being reduced. Lower times to deploy with beamforming, centralized management and control, all helping to get your network up and running quickly. Dense deployments. Network sync TDD frames allow more units to work together and share the resource. You've got single channel reuse and interference mitigation helping with that dense deployment. With .11AD, you start putting units close together, you'd often start getting interference due to the way it shares the channels. Network efficiencies. You can have multiple POPs, point of presence, allowing the capacity to be shared across the whole network. You can balance and reroute in that network. You've got coordinated scheduling between each of the distribution nodes, allowing you to share the resources across that network. High availability. With mesh networking, you're able to self-heal, and you're self-aware, you know where the problems are, and you can reroute around those problems. And then overall, about cloud-based management and centralized management as well. The network isn't managed on each individual radio. There's no need to go to client radios. It's actually managed in a centralized point, and any configuration is then distributed from that centralized point. Zero-touch installs. It's scalable from tens of units to hundreds to thousands of units over multiple networks. So what does that mean? We believe it's endless possibilities for service providers, whether you're supplying small cell backhauls, campus area networks, fiber extensions, urban, enterprise, or residential services. You now have a solution which is easy to install and get up and running quickly. Now, how's this done? Standards are great, but it actually we then take it. You know, we've been in the radio business for many, many years, and you've seen examples of how we've taken standards and we've improved them, whether it's if you've used the canopy-based systems with Medusa and the 450M, or EPMP, how we've, by synchronizing that, we've enabled Wi-Fi devices to be able to, again, be high-density delivery systems for fixed wireless. So how are we going to do this with this radio system? Distribution is we can string distribution nodes, they're called, along the street, connecting many clients along the way. So it's not a single point. You go from point to multi-point can be done, point to point can be done. But actually what you're doing here is distributing your backhaul along the area you want to cover. This basically means you can turn non-line of sight into line of sight by having multiple distribution points. Different long-range clients, short-range clients, different clients for different needs. Our range provides you the high throughput long-range client via the V3000, or if you want residential customers, short range, still you're going to get gigabit rates at around about 200 meters. You've then got your PTP, PMP, mesh topologies as well. So very flexible of how you can actually deploy this system. Then we have the tools for planning and deploying. So LiDAR-based tools, planning tools. The link planner, which if you've done fixed wireless access before, you know can help plan from point-to-point links to networks. We have mesh planning tools, enables you to put in redundancy and resilience. And then all this, as far as deployment is concerned, that automatic beamforming, it's turning the art of installation into, if you've got that line of sight, you just put the radio up, the centralized management system will configure that unit, and that unit will be online very quickly. And then, of course, we have on top of this a mature network management software platform, Maestro. You can manage the wireless. You can manage the wireless solution from the backhaul, fixed access, right into the home or office with CN Pilot through that single management system. As we say, the single pane of glass. So let's introduce the three characters that Cambium are using for cnWave 60 gigahertz and the multi-gigabit radio system. We have the V5000, which is a distribution node. As I said, this is where you distribute your backhaul along the street, along a town, and you can then, from that point, use the client nodes. And we have the V3000 and the V1000. I'm going to quickly go through the specs. I'm not going to read through all these. They're available for people to see. But this one is a very unique design. Whilst, again, we talk about the underlying technology and standards, Cambium Networks has taken these standards and done something different to the mainstream. We've provided this 280-degree coverage from a single unit to be able to provide support up to 30 other radios from this distribution point. They can be client nodes, or they could send and provide backhaul to other distribution nodes, up to 2 per sector. This allows, in a very neat small package, and also quite low power as well, at 35 watts, the ability to start your network from a single point and grow to many, many distribution nodes and many, many clients. The high gain node. In the past, we've talked about the V3000 having this 1 foot dish on it, and that gave up to 60 dBm EIRP. In Europe, you're allowed to use that up to 55 dBm EIRP. What we've actually added to this is, because of the uniqueness of the design, the way that we design this dish, rather than actually using a parabolic dish, we've gone for this design that allows us to actually just swap out the dish as an accessory to a different size. So if you want a smaller compact radio, we will be introducing next quarter this smaller dish, which still gives you around about 54.5 dBm EIRP. So perfect for the European market, and for when you want just to have a smaller form factor as well. So you'll see that coming soon, and this is just a quick introduction to that one. And then we have the V1000, which is, you could imagine, the residential client node. This will give you, it has a 1 gigabit per second port on there, and will provide that 1 gigabit per second to customers at around about 200 meters. I mentioned about many configurations, from point to point, point to multi-point, meshing, and we call it a sort of small cell backhaul, but it's actually like a relay where you can stretch from a single point. You can stretch your network to for a great distance. The V3000, for example, could actually go for many kilometers in as long as it's line of sight. We actually have a link, and I'll show you later in the examples, where it's been pretty rock solid for several months now at over 1.2 kilometers, providing 3.6 gigabits per second bidirectional rate. If you can imagine, you could string up to 15 of these together and cover a huge distance instead of putting a fiber trench in. And then, once you've actually covered that distance, you could then use something like a DN to then distribute that network to wherever you needed to. So I'm actually going to talk a little bit now about some trials that we've had going around the world. Now we're actually in full production of this and delivering products to customers as quickly as we can get them out of the door, both at the factory and the distribution centers. So, but we actually took focus on around about 40 sites around the world where we installed these units, and we worked with the customers to look at use cases and look at seeing how the radios performed. So we've actually got quite a lot of data from the field showing that how this works and how well it works. So let's go into a few of these. City center deployment. Just briefly, what do we expect from a city center deployment? We've got a rooftop to rooftop. You can actually point to point. You can actually join two offices together, or you can actually stretch that backhaul that you want to get from one point to the other. Again, rooftop to rooftop, PMP with mesh. This is linking multiple businesses together using these distribution nodes throughout at street level or at rooftop level. Broadband for business. And then going down to the street furniture as well. The size of these radios are neat and compact, So putting them onto street furniture, shouldn't detract from and shouldn't cause any sort of ugliness there, and it's not an ugly sight. Each one of those V5000s, if you look at the detail, actually has an auxiliary port on there, which has a PoE out. So we have a number of instances where we're actually powering the CN Pilot outdoor Wi-Fi devices and able to provide Wi-Fi hotspots throughout cities using that. Then we look at Wi-Fi Backhaul. So this is an example of an actual city where we've used where we've used our products. Here, we've got a smart city, around about 90 distribution nodes throughout the city, covering around about 60 to 70 businesses. And again, at each one of those distribution nodes, we have a Wi-Fi hotspot to provide city free Wi-Fi. We are actually privileged to be part of one of the biggest deployments of 60 gigahertz in the world, in Malaysia. Camera Networks was chosen to finish off and replace the trial network that Facebook did with YTL in Malaysia. This is around about 400 to 500 units are deployed throughout the city. Again, providing not only enterprise customers, but also residential customers for those cities. And once again, using that Wi-Fi coverage from the auxiliary port from that device. Wi-Fi is backhauled through it. Then we look at residential broadband. Residential broadband, you can see from this, where you can connect house to house through these distribution nodes. And again, you can stretch the coverage by CNs off each one of those distribution nodes. Let's take a look at some examples. So here in the US, we had an RDOF customer, it's like the voucher scheme, the rural voucher scheme in the UK, where they had to show they could provide gigabit access to subscribers, residential customers. So this plan here is covering a rural area. And as you can see on the right, we actually were able to do that over 200 meters, 250 meters. We were getting nearly 1.8 in both directions, upstream and downstream, to that residential customer. So again, we're looking at rolling this out to many customers to get this voucher scheme in the US. Likewise, in the UK, we have a number of examples where we're working with ISPs. Enterprise estates, we have a point of presence at the top of the picture in green. This point of presence can be used, this could be a fiber point of presence, and from that point on, you then distribute using the distribution nodes from building to building across that office complex. And again, the client, you can actually tap straight into those distribution nodes. You can see in the picture below, we actually, the office park in Devon, in Ashburton, where this is developed, you can actually see we've actually done that industrial park there with these radios. And once again, in the car park, we're providing that Wi-Fi access and all public areas. Private networks, campus connectivity. What we're seeing here is in universities, colleges, and even again, even larger office complex. We're able to distribute the WAN across from building to building. Once again, public areas are then offered the facility of the Wi-Fi access. We're getting around about a gigabit per second on that. Railyards, industrial applications. So where you actually want to have connectivity and reliability, we can do that again with the distribution nodes. We're covering railyards in the US. Industrial IoT, this is a massive chemical plant where we're looking here at each intersection point on the site of putting distribution nodes to not only backhaul the private network offer to office and factory to factory, but also sensor data for the production plan. And again, once again, people can roam around that site doing Wi-Fi roaming, backhauled again through the cnWave solution. With small cell backhaul, it's a slightly different story here. Well, it's here we're not actually doing large networks, but actually linking those small cells from one to another to be able to backhaul high throughput at very high availability. 5 nines, even 6 nines availability has been asked for, and this solution can ramp up even to that. What we have here in a city street in Asia, we're able to, from the 5G cellular stations, we're able to relay that data to 3 sites. They've got the fiber pop coming in at point B, and we're able there to actually connect the small cells CNA using the cnWave, and we're getting mean around about the 1.8, 1.9 gigabits per second, but we're actually getting that, we're getting over a gigabit at 6 nines availability. It's short range, but digging up streets like this, even for 100 meters, is costly and causes too much disruption. Putting up a radio like this can take hours rather than days. This is the PTP link that we've been practicing with. We've actually got a number of very long PTP links around the world. The longest one is actually 1.5 kilometers. This one is 1.2 kilometers. This is in Devon, and Devon, as you know, is very green for a reason. It's because it rains a lot. But yet we are still able to keep the link up and stay but rock solid. The actual throughput we're seeing from this, now we'll see a consistent 1.8, 1.7 gigabits in each direction. Now, all this, as I said, is managed from a centralized point. We have many ways in Cambium to do this. You can manage this if you wish through just for a local PC, and you go to the distribution node. For small networks, you can do this on the single unit. However, we have cnMaestro. cnMaestro is an excellent resource to be able to manage your network on, and many of our Cambium Networks equipment. So again, you can actually use Maestro connected to this either on-premise or on cloud. For even larger networks, you can, and for redundancy and high availability, that end-to-end controller can be taken off board and put into your server room. So you've got a lot of flexibility here of how you manage your system. Planning tools. If you have used any if you used any Cambium equipment over the past 10, 11 years, you know about Link Planner, how you can plan links to know what the availability will be, whether or not you can actually do a reliable link, and also what BOM you need, what bill of material are you going to require to do your network. All this has the cnWave built into it. And then we have the network planning tool, the advanced network planner, and cnHeat. cnHeat is a tool which, using LiDAR data, enables you to plan these complex residential areas where you can actually work out just how many DNs you need to get full coverage. As you can see in the example right at the bottom, there are actually hundreds and hundreds of client nodes, but actually with a few well-placed distribution nodes, you can get coverage of that whole residential area. So just wanted to really just give you a quick overview. What makes cnWave useful for both business and residential service providers. Whether it's urban, whether it's residential, whether it's rural, you can deliver gigabit wireless to your customers reliably and quickly, easy to install and easy to manage. From that, you can then add Wi-Fi devices. You can go indoors, and whether it's indoors or outdoors, you can actually then backhaul that data through this distributed system. And then as far as industrial is concerned, you have something which is rugged and robust to even for the industrial environment as much as the residential environment. So with that, I'd just like to pause for a couple of minutes, and we're just going to show you a little video.
"60 gigahertz cnWave. Wireless is the new fiber." People need affordable broadband connectivity wherever they are. But how can a service provider rapidly deliver reliable multi-gigabit connectivity at affordable prices in locations where fiber technology is cost prohibitive? And how do you provide coverage exactly where it's needed while containing costs? Deliver multi-gigabit wireless speeds without all the hassle of trenching fiber with 60 gigahertz cnWave solutions. Now you can build a multi-gigabit wireless fabric from network infrastructure to last mile access. With our 60 gigahertz cnWave solutions, service providers rapidly connect people with better connectivity wherever they are. Enterprises easily and efficiently manage a private network tailored to the business. Utilities expand service offerings to include broadband. Customize cnWave to tailor the network to meet coverage and capacity needs. Point-to-point bridges between locations. Point-to-multipoint distribution networks. Highly efficient mesh networks to provide blanket coverage around obstacles. Leveraging the 802.11ay standard, 60 gigahertz cnWave delivers reliable high-speed connectivity at a low total cost. 60 gigahertz cnWave system components include the V5000 distribution nodes that support 2 coverage sectors up to 30 clients in a 280-degree arc with a single module. Client node options include the V3000 high gain module and the V1000 mid gain module. Plan the deployment with our Link Planner and CN Heat software tools. Manage the solution and the wireless infrastructure with end-to-end visibility in the CN Maestro management system. Network operators choose Cambium solutions for high reliability, cloud management with the CN Maestro system, and low total cost of ownership. Operators can deploy wireless broadband and indoor and outdoor Wi-Fi networks with confidence that they will work, even in demanding environments. Deploy fiber-like speeds now without trenching cables. 60 gigahertz cnWave solutions from Cambium Networks make it easy to deliver and manage edge connectivity and connect people, places, and things wherever they are. Wireless is the new fiber. Start building your solution today. Contact Cambium Networks.
Okay, thank you, Anthony. That was very, very interesting as usual. I know we're a few minutes over, but just quickly, I've got a couple of questions just to fire at you. First one to do with the fact that there's several sort of Terragraph products coming to market. What's the advantages of the Cambium products over these?
Okay, I think there's a couple actually. We took a very close look at the standard. We took a look at the chipsets available and the solutions available, and it was clear we could do more. We don't just deliver just a standard product, a Me Too product. So yeah, you're not going to see anything like the V5000 is we've combined those 2 sectors. Covering a wide coverage rather than just 90 degrees or 180 degrees. You can put more of those on a pole if you wish, if you want to cover the 360. But actually, what we actually see in all the deployments is very rarely do you actually need that. And then, of course, those CNs, that V3000 is very unique. That high reliability, high power that we can utilize in Europe. So I do see that we've taken the usual Cambium twist and magic and sort of and put our mark on the standard.
Okay, and finally, how much radio experience do you really need to plan and install these radios?
Well, I think that's what we're really trying to do here. In the past, the first slide of taking it off the mast and putting it down into the street. That really means that you don't need to have riggers and climbers and go up a 300-foot mast to install this. You can go down to the street level and distribute those networks, turn that non-line of sight into line of sight. And then as far as the centralized management is concerned, you don't manage individual units. You put the unit up, it will connect, it ignites, as they call it. It gets the data from that centralized point, and you're up and running. So we're trying to make it as simple as putting a Wi-Fi access point up, and simplify that fixed wireless access solution.
Okay, well, thank you very much for joining us this morning.
Thank you. Thanks, everyone.